Hey guys, welcome back to AlgoYogi. We are doing linked list series. Our next problem in the list is copy list with random pointer. Let's visit the problem on LeetCode and go through the description. So a linked list of length n is given such that each node contains an additional random pointer, which could point to any node in the list or it could point to none node. So now we need to construct a deep copy of this list, and I'm not gonna read this entire thing, but just we need to create a deep copy. What is a deep copy? Exact same copy pointing to this same exact next pointer, same exact the value and the node structure has to be same, but it's completely separate. It has no relation with the previous linked list. So how do we create it? Let me change the view here. So this is how a list is given to us. It has a next pointer, like value is over here. It has a next pointer that's pointing to the next node, and then it has a random pointer that could point to any node. All right, this is pointing to null, but it could point to any other node. Now, so how do we create it? We could think about, okay, how about we just start iterating and keep assigning the pointers just like our original linked list is doing. But the problem with that is, let's say we start creating our first one, the copy of the first list, this first example. I create a node 7, and then its next pointer, I'm gonna create another pointer, basically 13. But then how about the random pointer? I wouldn't have any information about creating the random pointer because I need to first create those nodes and then keep assigning those random pointers basically. So I have to basically first create the entire list, and then I would assign the random pointers. But do we really need to iterate it? First create this with just with next pointer and then keep the random pointer null, and after that you revisit the entire list and then assign the random pointer. So maybe a better solution would be, if we are actually going to do it like that, then how about we just create all the nodes copy and store them into a hash map next to basically our old node pointing to the new node, and then we go again through our hash map, basically the old list, you can say the old this list, and then we go node by node and then see what is this previous the old node is pointing its random pointer to, and that's what we point our new, which will be accessible with big O and time complexity through using the hash map. So we'll use hash map. It's going to take big O and complex space complexity, but it will make our life easier for time complexity. So in order to access the elements that are already there. All right. So I think what will happen is we will have one iteration. So first step would be creating a list. So 7 is old node to new node, and the new node would be, so I'm going to write the old node, so 13, 11, 10 and 1, right? And then we will have 7, 13, 11, 10 and 1. But remember, these are all connected nodes. These are all connected nodes. They have everything set up, their next pointer, their random pointers, but these are just independent nodes, like just nodes. They have no reference right now. But then we will iterate over these nodes one by one, and then we'll see what is this particular node pointing its next to. It's pointing to 13. Then what we will do, we'll basically point its next to 13 and its random to some value, let's say none, because that was null over here. The first one was pointing to null. Then we'll do the same thing. Where is 13 pointing? It's next to 11, so we'll point it's next to 11, and then where it's pointing its random pointer is to 7. So that's what we will do. All right, so it's not, so my bad, it's not supposed to point over here. It's supposed to point to this. All right, because we have to keep this copy separate linked list. All right, then let's code it up. I think the code will be really simple, so let's go over it. So as I said, we're gonna have a hash map that will store old node to the new. So let's call it old to new, and then we basically have current pointer pointing to head, just to iterate. So it has nothing to do with the logic, just while cur. Now I'm gonna store, basically I'm gonna create a copy of list node, and then cur.value. So cur.value, that's what it says, and it doesn't look very nice, so I'm gonna just, you know, shift it a little. All right, then what do? We have this copy node, so I'm gonna just store it to my old to new hash map. So it will take, old is basically cur and new is our copy. All right, then we just cur equals to cur.next, and then what do we do next? So now we have our copy, and we have created basically this hash map where each current node points to the copy of itself, but it's an independent copy. Now let's connect all the random pointers, the random pointer for each node and the next pointer for each node. So again, let's have a current pointer that's going to start at head. That's the old original list, and then we're gonna have while cur. Now what do we do? So I will have the copy, I'll take out the copy from my old node for the current pointer. So I'll just call it copy, and that's basically coming out from, for the current pointer, from the old to new. All right, old to new. So I have the copy, the new linked list first node. This is the first node, I would say. Now copy dot next, this is what we need to set first, and copy dot random pointer. This is the second pointer that we need to set. And where do we need to set? It's gonna come from over here. So current dot next, because remember, this is some pointer. This is a node. This is basically a node that was pointing to the new list's corresponding new copy. That's what we want to assign to the copy, right? That's what we are doing for the next pointer, and the same exact thing we're going to do for the random pointer, random. All right, and then we just increment our cur to cur.next, and then what do we return? We don't have reference to the head of the new linked list. No matter, because we have this hash map, and we know its head will be pointing, basically not pointing, I guess, it has key as its head, and the value is the head of the new copy that we just created. All right, then let's zoom out and run it on examples, and I'm very hopeful that it will fail. And that's because we need this none pointing to basically none, right? Because we want to point, if it is none, then also basically we need to have it none pointing to none for the last node, because that's always none, right? So hopefully this will definitely pass. Yes. All right, see, I'm right about like not passing and passing, because never mind. Anyway, all right, so let's write the time complexity, which is complexity is big of n, and space complexity is also big of n because of our hash map. There's no other space that we have used. It's just the hash map, right? But that made our life so much easier over here, and the code is fucking clean. All right, then let's go to our AlgoYogi and mark this problem solved, and see you guys in the next problem, which is design linked list.